Welcome to Q-SYS webinars. This is our monthly webinar series, we do twice a month, I believe, where we cover various topics about Q-SYS, talk about various things. Today, we're going to be talking about how to choose the Q-SYS core for the design that you're building. So my name is Thomas Holt-Ronzi. I'm Senior Applications Engineer with Q-SYS, and I'll be covering the information today. I am running solo today. So normally I'm joined by my good friend Dan Waltons, who is one of our training managers. He is out today. So I'm running the presentation. I'm also running your Q&A. I'm also running the chat. So anywhere you throw information up, if I don't see it immediately, I promise I will respond. I'll make sure we have tons of time at the end for questions. If you want to ask a question, make sure to pop it into that Q&A section. If it's relevant to the slide that's on screen, I will answer it there. I may say we'll get to that if it's coming up on a future slide, or I may wait till the end to answer that question. But don't worry, I will hang around for a while and make sure that we get all our questions answered. So with that, we'll go ahead and jump right in to how to choose the right Q-SYS core. So today we're going to talk about talk about all the Q-SYS core processors, and we're going to talk about the steps that we go through in design engineering to select a Q-SYS core processor for a specific project. We're going to cover things like network topology and how that factors in, some of the considerations that you have to make when you're picking whether you want to use a centralized or distributed design. We're going to talk about some of the new cores that we announced recently, like the Core 24F, as well as some of the X-class cores. And then we're going to go through a decision tree. I've broken everything out into some nice, easy steps to help us pick which Q-SYS core we're going to choose. And we've also got some nice handy diagrams and stuff to help us along the way, as well as a handy dandy Q-SYS designer file that we can look at to see some other nice things to know about some of these cores. So just as a quick refresher, if you didn't know, Q-SYS is powered by a protocol called QLAN, and QLAN is a standard network protocol that takes AES-67 and combines it with the power of Q-SYS, so we can send audio, video, control, and data across the network through a single category connection, standard 1 gig backplane on everything. This drives the entire Q-SYS ecosystem, from the cognitive cloud. So you hear something like that, you think immediately Q-SYS Reflect, as well as anything that talks to Q-SYS Reflect can get that data from the Q-SYS core and from all of the Q-SYS peripherals. That's part of the Intelligent Platform OS. So that's Q-SYS OS. That's all of the data that you're putting into your room and driving that around the system. And that's also where our Q-SYS core lives. And then all of that is powered by our multimodal I/O. So that's things like Q-SYS peripherals like QIO boxes for audio and control, as well as touch panels, cameras. Anything that's got a Q-SYS label on it is part of this Q-SYS ecosystem. And then underneath that, we're supporting that with our physical Q-SYS products, like I just mentioned, the Q-SYS AV platform, so that's Q-SYS OS, Q-SYS Open, which is our standards, so things like CSS, Lua, as well as all of our open APIs that you can use to pull data out of Q-SYS, and also our Q-SYS partners like Microsoft, Sennheiser, Shure, Audio-Technica. You know them, you love them. But when we're talking about picking a specific processor, the first thing we ask is, what's the scale? So what's the scale of your application? Is this a small room? Is this a medium, like a small space is like a huddle space, maybe a small conference room? Or is it a medium space, like a lecture hall or an auditorium? Maybe it's, a high school gymnasium, something of that size. Or is it a really large deployment? Is this a stadium? Maybe it's an airport. Large distributed paging systems, hit that large scale answer. So that all leads towards picking a topology. So when you set up your Q-SYS network, you're designing for where those devices live in the space. So are those devices local to the room, one Q-SYS core in a conference room, everything is right there. It's all connected and, it all just talks at that local level. That's called a distributed topology. So maybe you have 20 rooms on a floor and all 20 of those rooms each get, a Core 24 or a Core 8 Flex or a Core Nano, and all the peripherals are right there in the room, display controls right there. Everything talks up to Reflect or can talk to other parts of the network, but you have these individual places around the network where you have nodes of AV. That's a distributed topology. A centralized topology is one core at the center of your AV network with all of the peripherals living in individual rooms. So maybe you have an NV32 behind a display in the conference room and it's running all of your local video switching, but the Q-SYS core itself lives in a network rack upstairs, where the IT guys can keep a close eye on it. And all of these peripherals are spread out around the facility. So that means that you have one design file, so one Q-SYS designer file that rules everything. Nice to build out and program. It also has a smaller footprint for processing power, so you have one core to pick from, and everything runs off that core. Also means you can do things like send cameras back and forth. There's different control things that come up with being able to have all of that information feed back to one central area. And it's nice it can be nice for maintenance. It can also be complicated for maintenance. That's where the distributed topology sometimes has pros itself is you can go into each room, take an individual room offline without impacting the rest of the system. You can also add new locations without having to update the entire campus-wide designer file. There's just a few different pros and cons for that. Also brings up, what these look like. So here's centralized topology, just as a little nice handy diagram. We've got our Q-SYS core and our network switch that is controlling a whole bunch of spaces. And in each room, we have our peripherals, our audio and control endpoints, our video encoders and decoders. It's nice, pretty straightforward. Inside our distributed topology, we at each of those 4 locations, so auditorium, reception desk, meeting room, and lobby, we have a core processor, we have a network switch, we have any peripherals that live there. All of that can still communicate with each other, but it's all separate. Now, because of the way that Q-SYS is designed, so every core has at least 2 network interfaces, with the exception of vCore. That has however many you build out, up to 4. LAN A is always your Q-SYS LAN. So that's QLAN. That's where all of your Q-SYS branded peripherals live. That's your AV subnet. And then LAN B, aux A, and aux B, those can be anything else. They can be Dante, they can be Control, they can be exclusively for Reflect, they can go out to the corporate network, integrate with things like Zoom and Microsoft Teams. That's because those are fully independent network interfaces. They don't talk to each other at a hardware level, which means you can do advanced network segmentation. When we do need to bridge those, we can do things like we can add things in like static routing that allows you to make a direct connection from that network interface to a specific IP endpoint or to a specific subnet if you need to. For instance, on this screen, you can see LAN B is addressed to the 1.101 subnet with a net mask of 255.255.255.0. That means it's only allowed to talk to the 192.168.1 subnet and all 255 devices that are inside of that. But we have a static route there at 192.168.49.0. That means that we are adding in the 49.x subnet, and all 255 devices that are there will be able to see Q-SYS, and Q-SYS can see those devices. So that helps you with doing some advanced network control. You can also enable and disable services per network interface. So you can go into Core Manager and say, LAN B, I am not using any of the APIs. I could turn off the external control protocol, JSON protocol, QRC, or the new QRWC API. I could turn those off on LAN B if I want to make sure that nobody is taking control of Q-SYS. It allows you to be very specific about what services exist on what network interface, which is really good from a network security stance. Just sending the data exactly where you need it and not anywhere else. So I mentioned that, scale drives these processors, but let's introduce some of our lineup. So we have two types of processors. We have our appliance level processors, which are baked complete off-the-shelf solutions that Q-SYS builds and designs, and those are things like the Core 8 Flex, the Core Nano, the Core 24, as well as the NV32 core. Those devices are appliance cores. They have I/O on the back of them. They also have a core processor. They do integrated audio, video, and control processing baked in. The other side of that is our X-class server core processors. So these are server cores. They are designed on server architecture. They have no physical I/O, and they drive larger deployment designs. These are really intended for those centralized topology models. And like you can see here, those tend to be picked as soon as you get to the large scale. Those immediately become your choices, your desired choices, because of the size of the processing horsepower under the hood, channel counts, things like redundant power supplies. But with our small and medium spaces, we have one more question before we just pick a processor. Obviously, there's a lot of questions that we can put in here, but the first one is, what kind of I/O are you connecting to that? Are you connecting analog microphones? Are you connecting loudspeakers? This might also be, are you connecting video? Because that might determine whether you want to use an NV32, a Core Nano, which has no physical I/O on the back of it, a Core 8 Flex, or a Core 24. So speaking of the Core 24, so we recently announced the Core 24, which is our successor to the very beloved Core 110. The Core 110 has been around for a long time. It's been around for 10 years, which is crazy in the AV space, to just have a single core that just lives that long in the ecosystem. But Core 110 and Core 24 both exist as this large do-it-all processor. It has a ton of I/O on the back of it. It has a ton of processing power. It can kind of hit any of those small and medium spaces, and we can solve a lot of problems with it. The Core 24 is the evolutionary successor. We increased the horsepower, we updated the I/O capability, and we, took a look at a few things that we used to have on the 110 and decided to bring those back. Things like the OLED panel on the front, we brought that back, as well as GPIO on the back. Then we doubled the processing power. So 4 times the processing power of a Core Nano, twice the power of a Core 110, 160 network channels. So these are QLAN channels or AES67 network channels. We also updated the Dante specs, so now it can handle 64 by 64 channels of Dante, 24 AEC processors, and we also upgraded the horsepower, so now it can handle even more peripherals than the Core 110 could handle. So if you get out your magic decoder ring for the Core 24, the 24 stands for onboard I/O, and the F stands for flex channels. This onboard I/O gives you a lot of power. When you have that built into the device, you can locate the core processor where it needs to be. That gives you a little bit more space efficiency. If you have a network rack that is small, and you don't want to clutter it with QIO boxes for audio and control, Core 24 is an obvious choice for things like that. And where this fits into a design, that medium space, like a lecture hall, that's a big space when you talk about I/O and peripherals that are going in there. So just to take a quick look at a line diagram here, I've got a Core 24 in the network rack, as well as a NS series switch, CXQ amplifier, some NV21, as well as a UC connected PC. So to answer I'll answer the question about 110F in just a moment. I'll just get through describing this room and the line diagram. But Room PC for UC connection, so we can have a virtual call into the classroom. Also, some wireless mics and transmitters around the room for assisted listening and wireless mic receiving, and an audio player so that we can play back some audio files. Maybe this is a music teaching space. So these kids are in here taking Theory 1, and they need to be able to listen to some listening tests and stuff like that. We've also got some acoustic design column loudspeakers, some network cameras, projectors powered by our NV32, as well as touch panels and NV21s driving delay screens, as well as our partners with Sennheiser. We've got some ceiling microphones in here and some loudspeakers around the space. All of that can be powered by the Core 24. This does mean that the Core 110 will be going away. Currently it is still orderable, but there are only a handful of those left in the United States, and once they are gone, they are unfortunately gone. So that we are bidding a fond farewell to the 110F, but the Core 24 does everything that the 110F did and so much more. On the back of that 124F, this will look very familiar to the Core 110 because the layout is exactly the same as the original Core 110. 8 microphone channels, 8 flex channels. So those are channels that can be either inputs or outputs. You get to decide programmatically. Line outputs, as well as some general purpose ins and outs. So if you need to drive something like an occupancy sensor, or you need to run a shade controller or a screen controller, something like that, you have analog or contact closure controls there. But what if the answer is, I need even more power than what the Core 24 has? I absolutely need to take advantage of large horsepower. I need a lot of AEC channels. I need a lot of processing channels. I need to have a lot more network I/O. So the Core X10 is the smallest server core that we make. So this is 256 network I/O, 128 channels of Dante, 64 channels of AEC. So this is a whole bunch of AEC for maybe a large convention space, or a small convention space even, that needs to be able to dial in and dial out. Maybe you have a large panel that you need to handle, as well as media and WAN streams. So these get bundled together because these are streams that are unclocked. So that means they don't use the network timing that Dante and QLAN use. They are just encoded audio streams that can go either across the layer 3 network as multicast traffic, or out to the wider world, which is what that WAN stream does. It'll actually put that audio out on the public internet if you can get all the way out there. Big thing with all the server cores that is a change from the older Core 610 is that all of these are fully capable out of the box with no scaling licenses. We got rid of those, and we'll talk about that more a little later. The big brother of the X10 is the X20R. So the X20R delivers twice the processing power of the X10, 384 network channels, 128 channels of AEC. This is also at a shorter depth to the older Core 610. Not a whole lot to talk more about the under the hood stuff. The big difference with this between the X10 and the X20 is that R designation at the back. So that R stands for redundant power supply. That means that there are 2 power supplies built into the back of this unit that can be pulled out on the fly, and you can swap those out. Or if there is a power outage, the core will keep running if that one power supply fails and the other still has power. That also means you can segment these to different circuits or different mains if you desire. You can go into full power and full network redundancy. All of our server cores also come with 4 network ports of a variety of types, as we'll talk about on the next slide. That gives you even more power for network segmentation. Finally, the last server core to talk about is the X50R. So the X50R is our newest addition to our core portfolio. This is a successor to the 5200, which if you've never used a 5200 on a project before, 5200 is a massive core that has a massive amount of horsepower, and we decided that it needed an upgrade. So this thing is a beast. 4,000 channels at 10 gigabits per second. This does have two fiber ports and two copper ports. So two RJ45s, two fiber SFPs on the back of it. That means that this can run at 10 gig per second. Backplane, you can directly connect it to a fiber switch and use that trunk connection for a whole heap of IO. 4,000 channels is you want to run an NFL stadium. You want to run an entire convention center off of one core. This is the processor to do it. If you're running at that standard QLAN 1 gig per second backplane everywhere, you get 512 by 512 channels. Dante capacity is 512 by 512. That is regardless of whether you're running on the fiber network or the 1 gig network. You can still use all 512 of those channels. 256 AEC channels. This also comes with those redundant hot swappable power supplies. Really gives you the ability to decouple that IO from your physical hardware. Also lets you optimize for network-based endpoints. Like I mentioned, you could have LAN A just be your AV subnet, with LAN B going to a UC network, and then LAN C or aux LAN A or aux LAN B could be used as reflect endpoints. And all of these server cores are meant to give you enough processing headroom for capacity scaling to really bring in new designs. New rooms get added in. Maybe the customer comes back and says, this is great, I want to add new features. And it also gives us room to add more to these from the software perspective, as we want to do. We like to put more stuff in these boxes when we can. Austin had a question. Are there any movements towards having larger capable NV devices to do video switching or with the ability to decode 4K out of both HDMI outputs? So not at this time. There's not, right now the NV32 is a workhorse. It's great. The NV21 is awesome for what it does, and the NV1 is great at what it does. Right now, stay tuned. That's all I can say. We're not done making video products. That's all I can say about that right now. Continuing on, so looking at what the X10 can be used for: divisible multi-purpose space. So this is a 4-way divisible room. It's a little hard to see on the left side there. Those tables are occupying are in front of one of our partition walls. So rooms A and B are open. Rooms C and D are closed. We have some NV. We have some CXQs. All of this is meant to be driven off of that X10 processor, which is sitting there in the rack ready to handle everything we need. Continuing on, and the X20R, this is when you need to expand beyond that. So we have a typical of one meeting room. So we've got some SPAQ, NV21, NMT1, just a tiny small huddle space, but we have 8 of them. So all of those are a standardized design that's run off the X20R. We also have a reception desk that's handling paging for this entire floor. We have a lobby that has its own peripherals there. And then we have that auditorium that has just the peripherals located in it now, instead of the peripherals, the core, and everything in one location. So this is that centralized processing model. And that's our Q-SYS core new Q-SYS core processors. I do have a handy cheat sheet that tells you, exactly all of the IO, all the Dante channels, AEC channels. This is your go-to for picking a processor. The good news is that this is not just localized to this presentation. This is on the website. You can go to qsys.com/processing and you can find that. Actually, I need to double check that link is correct. I believe it is, but I'll post it in the chat before I get to the end if it is incorrect. But qsys.com, under the core processors, you'll be able to find this one sheet to see everything that's in there. So going back to the final part of our decision tree. So if we don't have any of that physical IO and it's a small room, then we can pick out the Core Nano. With a medium room, you're picking something like an X10 or maybe a Core 24. Um, Depending on whether or not that has physical IO. If it's a small room with physical IO needs, then you can go with something like a Core 8 Flex or an NV32 core mode. It really depends. And taking our eyes and pulling them way back now, we've got that whole decision tree, looking at what size of deployment are we looking at what type of network topology, what our analog IO is, and then picking out the correct Q-SYS core based on that. Whenever I'm looking at the distinction between what is a medium room and what is a larger room, I tend to look at network IO and I look at AEC channels as well as Dante channels. Um, those are always things where those will be the deciding factor for jumping from, say, a Core 8 Flex to a Core 24. That those AEC channels really become important there. So had a couple of questions about design partitioning. So this is so Patrick asked it in the real. I'm gonna use Patrick's question because this is the nice and wide version of this. For the centralized processor, will we get the ability in the future to partition designs so that when we update, we don't take the entire system down? Currently, no. So currently with a X20R, X10, or the X50 Core 24, it's one Q-SYS designer version. So that means you have one Q-SYS file that lives on that core, and it controls any and all spaces that are connected to that Q-SYS core. Um, we've talked about it in the past about, and we've heard feature requests about this. Right now, I don't believe it's on the roadmap, but we're always making improvements to the Q-SYS software platform, and that may be something that happens in the future. I am not, I can't speak to that right now, but currently, if you need a large distributed design, but you want to be able to manage individual rooms and maintain those rooms individually, then you're looking at a distributed topology where maybe you're breaking that down to by floor. What I like to do is I like to kind of mix and match those two on really large designs and go for a hub and spoke topology, which is a little bit of a combination of the two, where say I have a 12 floor office building. Obviously, a centralized design makes a ton of sense for that from an IT management standpoint. So I may have, but I need specific spaces that are distributed. So maybe I have one core that runs all of the paging and all of the typical conference rooms. So, small huddle spaces and small meeting rooms that are cookie cutter deployments. Those might all be run off the centralized processors so that I can update the standard for those spaces across the entire organization. But important rooms, boardrooms, auditoriums, training spaces that might be changing a lot or might have more rotating needs, more maintenance needs. Those might get their own core, and I'll run those as separately from my main core processor and send control data back to the main core processor so that I have the ability to ingest that data for the entire network. Or also, if I need to receive paging in that unique space, I'll use something like the WAN streamer or the the paging station's remote PA functionality that allows you to page across cores now. So we're bringing out new features that make this less of a concern, but I do hear your feature request, and as always, I recommend if it's something like that you want to see Q-SYS do, heading over to Q-SYS communities. So that's developers.qsc.com. There is an ideas portal where you can make new feature requests, and those can get voted on by the community. And then those are actually read by our product marketing team and our product managers. and we look at those and we see how popular they are and decide how to prioritize things as far as roadmap options. So hopefully that gives you the answer. I know it's probably not the answer you would like to hear, but we are always looking to add more to Q-SYS, and we're not done here. We're going to do a lot more with Q-SYS in the future. Um, as with any Q-SYS design, whether it's centralized, small core, large core, uh, distributed, you always have the opportunity to put Q-SYS control into that design, leverage the Q-SYS control engine. Like I mentioned before, we updated our feature licenses over the last year, and we got rid of the UCI deployment and scripting licenses. We baked those into the cores, so that's a welcome addition. It means you don't have to pay to deploy a touch panel out into the field, and you can use all of our our large plugin library free. We also changed the scaling licenses for the Core Nano and the Core 8 Flex. So those do have scaling licenses that double the processing power on them. When the Core 110 was our medium IO based core processor, these would give you the power of a Core 110 in the size of a Core Nano. Now that sits in between the Core Nano and the Core 24. So you have another step in between. So instead of just having to go straight from my Core 8 Flex has the right IO, but it's not powerful enough. I have a jump between that and just having to go straight to purchasing a Core 24. And all of our future cores will come fully capable out of the box. As far as scaling is concerned, you do still have to purchase Dante licenses, but that's right sizing your deployment as opposed to trying to figure out which capacity scaling license I need to make sure I can run the correct number of plugins and have the correct number of AEC channels. So with redundant power supplies in the X20R and the X50R, there are a couple of caveats when you're connecting those up. So on the back of all of our server cores, there is an extra network port that you'll see. There's also a VGA port, which will be a throwback to some people. That extra network port is provided by Dell. So Dell makes the chassis underneath all of our server cores. That network port is called IDRAC. And IDRAC is a Dell protocol that allows IT administrators to manage and monitor server hardware and server architecture across a network. But it allows us to do other things as well, like control the configuration of those redundant power supplies. So inside of IDRAC, to set up redundancy for the core properly, you do have to go in and configure a couple settings. You have to set default power modes, turn on the AB grid redundancy. So otherwise it will power share between the two. So you can set up load sharing between the two power supplies, or you can set up grid redundancy where A is the primary power supply, and if that fails over, you end up falling back to B. Enabling hot spare on the primary failure so that when that power supply goes down, it slides over to the backup power supply inline. There's a couple of all those instructions will be found on our knowledge base. So support.qsys.com. We always put that stuff. Yes, all of that information can be found there. That's a helpful knowledge base for getting information. Roger asked, does IDRAC get a unique VLAN or will it be mixed in with Q-SYS? So I would always segment it because it's specifically a control data. This is something that your IT administrator, if they want access to IDRAC, they will ask for it and they'll give you information about where to place that on the network. You can mix it in with QLAN. It's not doing anything unique. It's just as far as I'm aware, it's a simple TCP connection for maintenance over the network. But I would configure it and then I would park that because for most deployments, nobody's going to need to touch it. One that's a set and forget type system. IDREC is also existed on the Core 610 and the Core 5200 as well. To answer that question, Chester, um, inside of Q-SYS Designer, there is only one property you have to change. Inside of the core, there is a property called redundant power, and you either set that to yes or no, depending on if you are using the redundant power supply or not. So you can power these off of one single power supply. You don't have to load share, but you do have to make sure that those settings are configured for how you plan to deploy either of those, either the X20R or the X50R. The nice thing about this being pulled into Q-SYS is that we can actually look and see the status of that in real time. So if I pop over to my Q-SYS design file, um, so here on the status for the server core, so I've got the core status block opened up. Um, because this is a redundant power supply capable device, we're going to see indicators for power supply 1 and power supply 2. We've also got verbose mode turned on, which gives us extra visibility to things like memory usage for control compute or network compute, which is how much network streaming bandwidth we've taken up. Process compute, which is things at the operating system level, and then the Lua compute, which is how are your plugins handling stuff on the network. There's also primary and backup indicators. So these will tell you the state of Q-SYS redundancy. So if you are currently using the primary Q-SYS core, or if you have a redundant core setup, what its state is. So if the core goes into redundant mode, that will actually send an alert to Q-SYS Reflect and let you know that, hey, we failed over to the backup Q-SYS core. You need to schedule a service because the backup will not fall back to the primary without manual intervention from you, because we don't want the system just failing, just recovering back up. We want somebody to go invest in and investigate why the system felt the need to fail over. You can also see a bunch of other information about the core and those DSP statistics, but we're going to focus back in on the power supply information, because we can pull that information out into Q-SYS and we can use it for automation. So I've got my core status block here, and in the properties, I've exposed the control pins for power supply status. So these are true or false indicators of which one is active. I've run that through a simple logic loop so we can see if they've turned off or not. And then based on the state of those, if they change, we'll pull the last entry from the event log, which is the last entry would be, hey, the power supply went offline. Fill that information into an emailer block, and we're going to send that off to somebody to alert them that that system has failed, the power supply has failed over. You will still see this information in Reflect as well. So if you're subscribed to Reflect notifications, or you have a webhook configured to send that message out somewhere, you'll get an alert that says, hey, the X20R for my new cores design has failed over to its backup power supply. I need to go investigate. So with that, the only other thing we wanted to show with this demo design is we've gone and put a whole bunch of peripherals into our inventory just to show the power of the Core X20. So this is an X20 we're running this design on, and as you can see, we've got 256 peripherals actually. So I'm going to run check design on this. This is probably running pretty close to the bleeding edge, right? Once it finishes hitting check design. So the thing about check design is it compiles your entire design and evaluates based on expected load. So we can see that, we've got my 256 peripherals here. We're using all 4 channels of our audio recorder, 128 of our audio player tracks, but networks and 120 network streams, but my processing is, I'm only using 17% of my processing. This thing's a behemoth. It can take a lot of processing capability. Obviously, we have more room for AEC channels. We have more room for Q-SYS NMT1 microphones. We have a lot of room to do more stuff with this, and we can also see down here. Check Design will tell you exactly what licenses you do need. So we need the multi-track player license. We need 128 channels of that. Those come in 32 by 32 stacks. So you just order enough to get to 128 or more. We also have a couple AV bridging licenses we need to put in here, as well as we have our software Dante. This does come with an 8x8 license out of the box. That's all of our cores have 8x8 licenses with the exception of the NV32. So with that, I'm going to go ahead and I'm going to stop sharing here and we'll open it up for questions. Hopefully this was illuminating, helped you guys see a little bit more of the insight when you call up your regional or local Q-SYS applications engineer and you say, hey, I've got a design file. What core do I pick for this? This is kind of the decision making process we go through to look at this. Obviously, if you send your design to me, if Roger, who's actually in my territory, if he sends me a design file and says, hey, will this work with Core 24? Obviously, I'm looking at it from a little bit more of a granular level, but this is a nice rule of thumb to get you there. So yeah, thank you guys for joining. I'm going to hang out here for a while if there's any questions. Yes. So, Stephen, this recording will come out. It usually takes a couple days, but there will be an email that comes out with the recording of this presentation. So you can go back and look at it later. With the new server cores, are we still able to use serial ports as contact closure for life safety? So the server cores have no physical I/O on them. So to do life safety contact closure, you would add in a QIO S4. That would be or actually you'd add a GPIO 8x8. So that will be the 8x8 GP general purpose ins and outs. And you could use serial as contact closure. I probably would just use a GP 8x8. But to answer that question more specifically, the server cores have no physical I/O on the back of them, so they wouldn't be able to do that without an extra QIO box. Thanks. Let's see. So what we didn't talk about with in this presentation, as far as those I/O expanders, there are a whole portfolio of I/O expanders that we can use to add I/O to a server core. So I mentioned the GP 8x8. There's also the S4, which is 4 serial connections. The first one is RS422, 232, or 485. The other 3 are just 232 ports. There is also there's a whole slew of the control ones. We also have our ML4i, L4O, and the ML2x2, which are small little quarter rack mic line or line level input output devices. And then we have our high density expanders that come in a couple flavors. My personal favorite is the 24F, which is a Core 24 with the brains pulled out of it. So if you need more power than the Core 24 has, but the Core 24 has the exact right amount of I/O, you can get that QIO audio expander. The 24F audio expander comes with 2 network ports, so you can do network redundancy for that product. All of the high density QIO boxes have dual network ports specifically for that purpose. So looks like we're starting to, let's see, where you would use, is there a scenario where you would use an NV32 and a Core Nano? So typically if I need an NV32, If it's located behind the display, I can drive the display or the projector directly from that NV32. I will try and make the NV32 as a core work because it has its own, it's a little less powerful than a Core Nano as far as AEC and processing and peripherals, but it's a very capable box itself. So I can decode from the network with that in core mode so I can have all of my distributed inputs around the system, throw it behind the display, use it as a dual display with local switching for my UC compute. Um, if I need a USB bridge somewhere else in the design, I might pop a Core Nano in there. If I need a USB bridge at the table and I need like a contact closure for a mute button, I'll throw the Core Nano in there. We do still have the IO USB, which is a little USB Brit 2.0 bridge that's designed to fit under a table. That has an RS-232 port on it, but if you need contact closure, I might add in the Core Nano as well. Or I'll use the Core Nano as the base processor if I need more AEC or I need more Dante, and then I'll use the NV32 as a peripheral. It really depends on what I think I can get away with the NV32. If I'm hedging on that, I will throw the design together in Q-SYS with just a little bit of audio and stuff just to see how it looks on an NV32. And if I think I'm running close to the sun, I'll just upgrade to a Core Nano. Are the ports on the new servers similar to the old cores? Audio on LAN and A and B, no audio on aux A and B. Yes. So on the X10 and the X20R, they work exactly the same as the old 610 and the 5200. The X50R has LAN A, LAN B for the fiber ports and the copper ports. So it depends on how you're using the X50R, but the other cores, the X10 and the X20, it works exactly the same as it used to. X10 HDMI and USB ports and X20 VGA and USB ports are not supported per the user manual slash quick start. Are the USB ports on the X50R supported? No, they are not. So all of those physical I/O ports, the HDMI's, USBs, RS-232 on the back of those server cores, all of those drive straight to the Dell OS, to the Linux OS under the hood. They don't actually go into Q-SYS, and we don't light them up in Q-SYS. So none of those are supported. And there's, to that point about the USB, there's no USB bridging on an X50R. All right, lots of great questions. Let's see. Keep them coming. Try and clear out my screen here so I can see more stuff. But yeah, generally with the cores, I usually try and just, this is me just as a designer. I always try and max out the core I'm working with before I jump up to the next one. Um, Typically I'll give myself a 20% margin. So designing up to the processing hits 80% mark, or if I think I'm within the 20% of AEC channels, that's when I start to look at the next core up if I need to, or if I need to start doing some more design consideration to try and figure out a way to make, if I need to make it work in a Core 24, then I'll look at other stuff to try and figure that out. Usually Dante and AEC are the hard blockers that will force you up to a next core size, but pretty much everything else around that I can try and solve for. Let's see. So new questions. Both in a room to get to. Speaking of of an NV32 and Core Nano, I had to use both in a room to get two camera feeds for a Zoom room. Is I'm assuming you're talking about Sam, you're talking about something like video compositing or like a split screen view for a single USB bridging output. Um, I don't believe it's on the roadmap right now, or I can't really speak to roadmap too much. Just generally, I'm very limited on what we're allowed to talk about as new and upcoming products. Um, I don't believe it's on there right now, but we are we are aware of the need for things like, multi view, multi feed views in Zoom Room, and supporting things like multi-camera mode. I know Microsoft is working on features like that for Teams as well. So there are features out there now that we want to be able to hit. In the meantime, you did it exactly the correct way that I would design it, which is two USB connections to support multi-camera mode in Zoom Room. Um, Yeah, so the only product right now that does a split screen view is the NC90 small format camera. So that is a 90-degree electronic PTZ camera, and it comes with a couple unique features. Active speaker framing. It's got some microphones built in that it can do a baked into the camera auto tracking, auto framing, where people are sitting around the space and it will actually find you based on where your audio is coming from relative to the camera. It also has a room and tile view functionality where it will take every person in the room using face detection and it will split them up into their own Brady Bunch squares, as well as the ability to have a dual camera feed of the wide shot and that tile view at the same time. So for very small rooms, less than 16 people, 25 feet deep, the NC90 can do this today over a single USB connection, but none of the other NC series cameras can right now. Let's see. It looks like what about point-to-point video endpoints where it's a singular ingest and singular output native to Q-SYS? Right now, I don't need the power of an NV32 with the amount of streams it can ingest, but its form factor is useful for the size it is. So I think you're talking about a single output decode and a single input encode. Right now, I would use the NV21 for that. That has less power than the NV32, but it can still bring in a single HDMI connection at 4K. It can output a single HDMI connection at 4K. Also has that USB-C connection for, USB power delivery, video ingest, bridging. I would use the NV32 for that point to point with Q-SYS. All of our NV series products do require either having a core or having an NV32 running in core mode, because they do have to. The subscriptions are all managed by Q-SYS Designer, and then the video is point to point over the network. Let's see, still got a bunch of people in here. This is great. I could talk about this all day. So please keep the questions coming. Especially, I like the really specific questions. It sounds like some people are their brains are already churning, looking at ways to maybe redesign that project you've got about to go out for quoting. Um, maybe you can fit more rooms in the core you have. Uh, yeah, just keep chatting. We got, we definitely have more time. I know we've got 5 more minutes before the official end of the webinar, but I can usually hang around for a while longer and answer questions. Um, Make sure to reach out to your local Q-SYS apps engineer. So that's me if you're in the Northeast. So I cover everything from Virginia up to the Canadian border and west to Michigan. So it's a pretty big territory. Me and Eric Marchitelli cover that together. We also have application engineers for every other territory in the United States. We also have engineers in South America as well as Europe and the Asia Pacific market. So there's always somebody up available to answer your questions. All right. Well, if I don't have any more content for you, so if there aren't any more questions, oh, actually, yes, there we go. Yeah, now the questions roll in right as I was starting to vamp us out. Any idea when the Experience Center in New York City will be ready? So, the good news on that. So we, for everybody who is not aware, we recently talked about opening an Experience Center in New York City. So we currently have Experience Centers in California at our Costa Mesa headquarters, as well as Austin, Texas. These are places where you can come and experience Q-SYS training in person, taking either our level 2 or our control and UCI training series in person with Q-SYS teachers. We have dedicated instructors who run these courses. Usually myself or one of the other application engineers rolls along as well. We try and have a good time. It's a great place to hang out. These are buildings that are packed full of Q-SYS, so we show you a lot of stuff, give you the tour of the land, and we recently announced that we'd be opening one in New York City as well. They are in the final stages of opening, so we're actually running some of the first classes we'll be running this spring. Reach out to your applications or sales rep. Your Q-SYS area sales manager will have information about if you're in the Northeast and want to attend. We'll have links. Roger, make sure you shoot me an email, and I'll let you know specifically when our territory will be able to go into that experience center. I am currently in an ecosystem with a number of 110F cores. What do you anticipate is the lifespan before needing to replace these for the 24F? In other words, how long do you anticipate the support to continue for the 110F before needing to replace with the Core 24? So, depending on when you purchase that core, there's a warranty for each Q-SYS core. Obviously, Core 110 is currently available in the latest version of our Q-SYS long-term support firmware. So the LTS, which is currently at 9.13.1, is always supported from our support team for 2 years following the release of that firmware version. As far as physical cores go, my attitude is replace it when it breaks. And if you have any questions about it, please call our Q-SYS service team. The Q-SYS support and service team are really good. I think the average wait time is like under 5 minutes. They're really proud of that. I know that all of those guys work really hard to make sure that they are always helping people and trying to give good answers. And when they don't have the good answer, they go to somebody like myself or a software engineer and find the correct answer for you. If you're designing new systems, I would design them around the Core 24. But if you have a working Core 110 right now, it's going to be supported in Q-SYS Designer for the next little while. I believe I'd have to I'll double check when we the last core that went out of support. Because if you go into our Q-SYS help documentation, we do, under the planning section, have a Q-SYS compatibility chart that tells you what hardware is compatible with specific versions. So we have both when the first firmware version that supported a specific piece of hardware, like 10.1 brought in the Core 24 or the QIO 24F. 10.0 brought the Core 24, and also what versions we stopped supporting specific hardware on. So the Core 110 is still supported in the latest version of Q-SYS Designer 10.0, unless it was made prior to 2017. at which point 10.0 is your jumping off point, and I would stay on LTS. Other cores that, I mean, we have legacy cores that only recently went out of hardware support. The Core 3100, which if you Core 3100 and 1100, if you have been around long enough to have integrated those, congratulations. It is now time to start looking at refreshing those cores. They haven't been in production in many years. Yeah, the 110F shell. So with servers having no USB, is there a roadmap for USB bridging peripherals and USB 3.0 peripherals? So I can't speak to roadmap right now, but I know I was looking to the QIO platform, and QIO peripherals we're building more of them all the time and designing more of them all the time. We do have a prioritization for what we're putting out there. The QIO 24, the ML24i, and the L24O were just released back in November. So those were the latest QIO products. So I'm sure that team is hard at work designing something else for the QIO platform. When configuring a Netgear AV switch, so Gerardo, I'm assuming you're referring to a non-Q-SYS branded Netgear switch to support the QLAN network for a Q-SYS core. What is the recommended port profile or configuration when the switch is also supporting devices from multiple manufacturers outside of the Q-SYS ecosystem? So for context, if you purchase a Q-SYS NS series switch, it's configured out of the box. It is a Netgear AV line switch. It's an M4200 series. If you purchase an M4200 AV line switch from Netgear, you out of the box, it has an AV configuration UI, and that comes with a bunch of what they call port profiles, which are specific settings for VLANs. And there are a number of Q-SYS port profiles that Netgear has helpfully built for optimizing things like Q-SYS audio and Dante, Q-SYS video with Dante. What I would recommend is taking a look at those other manufacturers, look at what their requirements are, look at our network requirements documentation, and make the decision on the port profile that works best for that specific system. It's unlikely that there is a port profile that is a catch-all for all manufacturers that aren't labeled Q-SYS. My go-to with that tends to be the Q-SYS video, or the Q-SYS audio with Dante profiles. Those have the most they're the most designed to integrate with other things outside of Q-SYS. So the NV21 does not support MediaCast input to its component when in decoder as of now, whereas the but is there plans to bring that capability to the component within Q-SYS Designer in the future? I am not certain about that state. I know that we want to bring features like MediaCast decoding to the NV21, but it's a software-based integration to add new features to any of our products. So it's really something that has to go through our software engineering process. I am not sure where that is, if that's on the roadmap right now or not. But I know that we want to make those NV products as powerful as possible. All right. Well, we did it, guys. We got right to 12 o'clock. So it is a few after. Thank you guys for coming. I'm gonna hang out for a few more minutes, so feel free to ask some questions. But I am gonna go ahead and officially close down the webinar. Thank you guys for coming. The recording will be out. If it's not out today, it'll be out over the next few days. In the meantime, check out the Q-SYS website for upcoming webinars. I think we have a couple upcoming that are going to be really interesting. The next one's out. If I go to my handy dandy upcoming list, we are doing advanced CSS techniques. So using the Q-SYS UCI tools to design CSS templates and how to bring those into Q-SYS. That's coming up. That's going to be on March 24th. And then on March 31st, at the end of this month, we are doing a Room Suite Modular Systems deep dive. So we're going to be showing you how to design rooms for Room Suite and how Room Suite integrates into those small to small medium spaces that you want, and you guys are probably looking at where does that fit in. We have all the questions for you on March 31st. So go ahead and register early for those. I'm sure that Room Suite one is going to be jam-packed. So thank you guys for coming, and have a great afternoon.